Yourself.
Yeah, I'm Randy Birdsall, as it says. Hello. What I want to show you guys is kind of a realization of everything that Amr just said, covering a whole slew of products. And to do that, I am going to unplug for just a second, so bear with me. Need to get all my VPNs up. While I do that, you guys can take a look at these cool toys that I'm going to be showing you in a second. What we've got here is a bunch of sensors that are connected to a PLC. The PLC then connected to this Cisco IRE29, and we're getting data off of this, and we're going to include that in part of the demo. And I'll make sure we're good here. First thing I want to show you guys is what the OT folks actually care about. Okay, so.
Are you guys familiar with that term, OT?
Sorry, operational technology. All right.
Basically not IT.
All right. So what OT cares about is not that big, nasty diagram that we showed before. It's critical for the success of any type of manufacturing deployment, but this is what they care about. This is what Amr was saying. It's MPCNC, machine performance for CNC. And if you look at it, you'll see things in here like spindle speed and feed path rate. That's what the end goal is. IoT is always about that end goal. What's the business value you're trying to get to? It's not so much about what components do I need to deploy in the network, how do I configure my ACLs. The OT guys who actually have the checks that they're going to sign and give over to our partners and us, they don't care about all that back-end stuff. This is what they want to get to. But to get to that, we need to leverage the network diagram and infrastructure that Amr was showing. So I'm going to take you through how we actually make this real. I'm going to switch over here to this PowerPoint and move to my first slide. You saw this with Amr, and I just modified it a little bit to try to make it a little more obvious as to what different components were. So in the data center, we're going to have our network management and security components managing device connectivity down at the edge. And so I'm going to talk to you about secure connectivity first, because that's the very first thing we need to do, is how do we actually get down, push the network down to the edge. To do that, we leverage, oh, come on now. We leverage Industrial Network Director, which handles managing all of our switching infrastructure, Identity Services Engine for handling access control, StealthWatch for anomaly detection, and finally down at the edge we have our industrial switches that are managed by ICE and IND. So if we take a look at IND, IND is going to be an OT-focused view into the network, because they're not going to be familiar with a lot of the concepts that you guys on the IT side are familiar with. So we need to make sure we simplify it and give them the information that they actually care about. So in this IND instance, we're showing the dashboard here that gives you a view of the types of devices that are deployed on the network. Right? So you don't see things like routers in here. You don't see things like firewalls. They're going to care about the controllers and the HMIs, or human machine interfaces, or I/O devices that are on the network. And these are actually automatically discovered. So it's based upon a templated configuration that you would create, and then use Cisco PnP to have the switches that you deploy automatically get configured. But I want to take you to the topology. So once we've gone and discovered all the devices automatically through either scanning the network or through Cisco PnP, we build out a topology map for the OT person to look at. And you might look at this and say, wow, we've been doing this forever. This is no big deal. We're just discovering the switches. But what the difference here is Industrial Network Director understands the devices down at the edge that we're connected to. So they understand that this is a Rockwell Automation PLC. That's connected up to a particular machine using the SIP protocol, not SIP, CIP. And understand that has 4 slots. So it is now aware of the devices at the edge that are industrial focused, which is a unique characteristic. Now that we've got visibility and connectivity down there, we have to deal with the #1 challenge right now for IoT is around security, because the stuff that we're bringing onto the network, when they designed that hardware and the software and the protocol, security was not something they cared about, right? It was like, we just need to get some data off this and we'll do it as quick as we can. So you need to apply security policy in the network to do that. But if you ask an OT guy, go configure up some ACLs, right, and go set up a firewall, they're going to look at you cross-eyed and they say, I have no idea what to do. And they've got to then collaborate with IT, and then it turns into this really long, drawn-out process. So what we decided to do was provide a really simplified way to do that. I'm going to take you over to a human-machine interface that we developed. Here we go. All right, so you can see here there's two PLCs, one on the left in cell 1, one on the right in cell 2. You're using the SIP protocol to communicate to each other. This is not a good thing. These devices are in different cells. They should not be communicating. Back to the Merck reference, when Merck had the NotPetya go running wild all over the factory, they shut down production and they lost $300 million in a quarter, all because they had a big flat network, right? That is not the way we want to design it. It's got to be segmented. But again, if you go back to the OT folks who are making these buying decisions, they don't know how to deal with that. It's not something that's in their wheelhouse. And IT and OT don't seem to like each other very much. So
who generally owns the solution? Because the first step in any successful IoT project is going to be bridging the gap between OT and IT.
Yep.
When you're deploying these solutions, are you talking to OT or are you talking to IT? I mean, it's going to be customer specific, but in general, who is doing Kinetic? Are you working with the OT guys?
So it always starts with OT, because OT has some type of business problem they're trying to solve, and we'd work with them to say that that's a problem that can be solved and we know how to do it. Then they bring IT to the table, and we start talking with both of them simultaneously. And typically what will end up happening is we'll have partners both from the IT side and the OT side that they're already engaged with, and then we'll have some type of SI that helps bridge the gap between the two of them. And then you might have also another partner that's handling the business analytics side of it to do the actual visualization and running reports and analysis and all that. That wouldn't fit in the normal wheelhouse of OT-IT partners.
Gotcha. Like from the network side, a lot of the times I'll see IT will own everything down to the cell area zone, and then in the individual cell, you're going to have vendor managed solutions where they've got their own kind of integrated solutions. But this looks like something that would be more managed by OT on a day-to-day basis, or what do you?
Yeah. So in that interface I was showing you, this is definitely targeted towards the OT person. And there are integration points that IT needs to get involved in. So to enable this, and what I'm about to show you, to enable integration between IND and ICE, OT and IT have to come together to solve those problems, right? And so we're part of the bridging process for that, right? When they say, hey, we need to secure our deployment, how do we do it? We're able to come to the table and say we can solve it for both OT and IT and bring them together.
Gotcha.
So,
but you're absolutely right. This is like a tension that's really there, and it's like one guy's like, I'm the guy who's making the money, let me just do whatever I need to do, and the other guy's like, I'm just trying to keep you safe.
Yeah.
Right?
I've seen it on every IoT project I've worked on.
Yeah, it's a bit of a nightmare. So this is what empowers the OT though, right? So we're showing over here, these two PLCs, they're chatting away. You can see the ones and zeros in the middle of the screen. We can come over here, and the OT person knows that this Rockwell PLC and these other HMIs, they all should be in cell 1. They can just highlight those devices and apply a tag, right? And by doing this, we're actually integrated with ICE, and we're passing over the information about these devices and what tags should be applied there. The OT person doesn't need to know anything about how to configure it. Just know that, oh, those devices are part of cell 1 or part of cell 2. Once those tags get applied, ICE gets automatically configured. And if we jump back over here, you can see now the messages have stopped going between those two PLCs. Eventually, a connection's completely lost. Okay, so that's given that power to the OT. They don't have to go to IT to solve the problem. IT doesn't have to spend the cycles working on that. Let's go to the next logical step. We've got segmentation going on, great. But all of a sudden, this particular PLC down here that we pulled up, this Rockwell, is having an issue. And we need to get support from Rockwell to come in and work on it. Typically what would happen is they'd reach out to IT and say, hey, we need to get VPN access to our DMZ for this Rockwell guy. Then you need to set up some ACLs to allow him to get access to this and only this machine. Can you help me do that? And then they have to figure out how they communicate about enabling that. Instead, with the integration with ICE, we can do things like this. We can come over and apply a security tag. And the OT person can say, I want to add remote access to this device. Now let me jump over here. You can see here's the VPN, IPsec VPN. We're going to open up a connection to .34. That was the PLC that we were trying to give access to. You can see down at the bottom it says .34. Kind of small, but trust me. If we jump back over here and we apply that remote access tag to that device, and then jump back in and open up the connection. Now the OT person is granted access to Rockwell just to that PLC, and all they had to do was apply a tag. They didn't have to understand how do I configure the whole security piece of it. That's really powerful. How are we doing on time, by the way?
You have 16 minutes. There's a little
16?
here. I don't know if you can see it.
I can't see it.
16 minutes, you're good.
Awesome, cool. So the next piece of it, from the security angle, is going to be around StealthWatch. So in addition to integrating with ICE, and ICE's integration with StealthWatch, we can integrate directly from IND to StealthWatch to pass along some of those tags and information. So when you have a security incident and an IT person sees, oh my gosh, I'm seeing an anomaly in the traffic, StealthWatch sends up an alert. Usually it's got an IP address, it's got a source to destination port, and then they reach out to OT and say, hey, port X, Y, and Z is having a problem on IP address, blah. OT guy goes, I don't know what that is, I don't know what you're talking about, I'm not sure how to help you. Once you get that integration happening, and the OT person is assigning tags to different devices in the network, then you start getting insights here. Let's see if I can zoom in so you can actually read this. On this line right here, you can see that if they detect an anomaly here, we've got, okay, this is a device that's in the Austin plant. It's an HMI. It's using the SIP protocol. It's in cell 1, and it's a controller. So all of a sudden, OT and IT can start having a conversation together where it starts making sense, where the IT person says, hey, cell 1, it's a Rockwell controller. It's using the SIP protocol, and it's a problem. And so in addition to that, StealthWatch is aware of protocols like SIP, Profinet, BACnet to detect those anomalies in the traffic. So in both cases, what we're trying to do, back to your question, was how do we bring IT and OT together? We need to give them some common ground where they can start communicating with each other. And that's what we're doing here. So what we've been focused on, though, is a deployment where you have centralized switches in a factory floor, for instance. What about the remote scenario? I was actually talking to someone on the show floor. She worked for a mining company, and it's a fly-in site. And it was a really cool, I actually took her around and made her tell everyone's story about how their company operates. They've got trucks that are autonomously, some of them are autonomous, some of them are remote controlled from hundreds of miles away. They have scoops and conveyor belts that are all autonomous, and they'll go and scoop up the rock and dump it on the conveyor, take it out, the next scoop picks it up, puts it in the truck, and then someone remote control drives it around. But they've got no IT staff in that site, right? It's just a couple of people making sure those machines are operating. So how do they deal with that, especially in the IoT world? So we have a solution with Kinetic that allows for cloud-managed IoT gateways. This is the portal that allows you to see all of the gateways that are managed, just like this gateway here. The idea would be, let's say we take that mining situation. You've got, hold on, let me sign back in. You've got a device that would be pre-configured and then shipped off to the customer. The customer would then have a stack of them, and they could ship them out to all of their remote sites. And once that gets online via like LTE backhaul, they'd be able to automatically provision, configure, and manage it all from the cloud. And here you can see we've got 15 gateways. These are all part of our demo kits, these little beautiful boxes, all spread around the world. You can see there's one down here in Florida. That's this one right here. So let's go ahead and click on that guy. So this gateway is completely controlled and managed by the cloud. No access any other way. You can do everything that you need to right from here. And let's take you through how we'd actually do that. Similar to what we did with IND, we have templating. So we would go here and create a template that we'd apply to a collection of gateways. In this case, this is our template for network configuration for all of our demo kits. And in here, it's really simple. It's designed that it can be it's as OT friendly as you can be when you start talking network, right? You can turn on and off features with a simple toggle. We will predefine the network and handle all the NATing. So if you want to, though, you can also configure your own customized network, which we've done here. And if we start talking about how do we secure the data coming off these, we also have site-to-site VPN, which is a simple checkbox with the remote site IP address as well as pre-shared key, and then you're off and running. So you'd be able to get data off this at that mining site back to headquarters, for instance. So once you've created that template, then you can apply that template to a gateway. So here we have all the gateways that are being managed in this particular org. We can go ahead and create a new gateway. You put in a serial number here. So this is something you would do ahead of time, right? You've got your stack of gateways sitting in your warehouse. You'd go here and dump in all your serial numbers. You would put in the model that it would be. Set any of these custom fields. So all these fields you see here on the left, these are all ones that you predefine that you might want to use for management, reporting capabilities. You can also use it for policy. Once you fill that all in, you come in here and you can either create a new template, use a save template. We're going to use our demo kit template that we saw before. And then at that time, we can also customize it if we want to tweak anything. We go next, and then we can deploy applications on it, which I'll touch on in a little bit. And then you're done. Once you've done that, this gateway, whenever it gets connectivity, which would require at the mining site, for instance, they would just go ahead and power it on, and then they're done. Right? It would use the LTE backhaul to get connectivity, or it could have pre-configured access to the whatever Wi-Fi network they had there that was then going over some wired connection. And then it would be configured, the network would be handled, and then the application would be deployed, and we'd start being able to get data off of it. And this would be something that you could do at scale. Thousands of gateways, not just a handful of them. So this kind of covers the remote IoT gateway solution. The IND piece that we covered at first would cover your centralized like factory floor. Everyone cool so far? Like awe-inspired? Just got you guys just ready to fall out of your chairs? All right, good. Jump back to these slides here. So now I want to talk about data management. So now that we've got connectivity down at the edge, we've secured the network at the edge, we need to be able to do something with the data. We need to be able to extract it. So for that, we're going to rely on Kinetic. It's got a data broker that runs at the edge. So inside this IR829, we've got IOX, and inside IOX we can run apps. And we're running Kinetic here, and specifically the data broker. The data broker, as Amr mentioned, has a number of connectors. Right? And let me just disconnect my VPN. Connect over to the demo kit. Those connectors, there's a laundry list of them here. And they provide two functions. One would be to extract data, and one would be to push data somewhere else. It could also be used for processing data if you want to write a link to do that. But in our case, in this demo, we've got this box with a PLC in it down here that's doing Modbus over TCP. So we're just connecting via Ethernet and communicating over TCP with Modbus. But you can see here there's lots of protocols that are supported, BACnet, Profinet, and that can be done over serial or over Ethernet. Doesn't matter to us. And once you build those links, now you're able to actually extract the data. So now we've got the app here that we sent down from the cloud-managed interface. We deployed that app with a link to speak Modbus to this device, and now we can get all the information about these sensors coming out and inputs. Now, once we have that, what do we actually do with it? You need to apply some type of logic. And Amr alluded to this. It can happen in two places. One is the edge, right down in near real time, next to the device that it's connected to, or you can do it in the fog where you've done some kind of aggregation. What we're doing here is I'm going to extend all the way down to the data flow that actually powers this. And what's cool about this is this doesn't require any type of program. You don't need to know a language. You just drag and drop logic blocks, and then you connect up those arrows, and you can start to process, manipulate, normalize, and move data around your network. And it might be hard to see, but let's say we turn the vibration up. You can see right here where my mouse is, see that number going up and then drop down. So in real time, you're seeing what's happening. We're taking all of this input, we're putting it into a single object, bring it all together, and then we're able to send it off. Now, what would we send it to, you might ask? Well, people like to visualize things, right? People want to be able to see the data because just saying we're getting it doesn't mean anything. So we have the ability to create lightweight visualization at the fog layer. It's built into the data broker. It has to be licensed separately, but you can use it to build interfaces like this. So if we take a look at right here, we can see the vibration value. increasing here, right? And then you can dive deeper. You can look at your graphs here. You can see vibration down at the bottom, okay? We've also built a lightweight HMI here, and I want to show you something that I think is really cool. It's important because we've been talking about getting data out over and over and over and over, right? But we can also get data into it. So here you can see from the HMI, I'm able to push controls down to the PLC, and you can see the lights changing on it. And then likewise, I can take action here and have it reflected in the HMI. You can see the input 1, input 2 lights changing as I press them here. Okay, so it's bidirectional communication through Kinetic. All right, so that's what we're able to do on the edge. Now I want to show you something else. Take a look at this light. Being able to do things at the edge, I think, Amr, you mentioned the scenario where they bent the probe that was detecting temperature, and we needed to do some processing at the edge to increase it. So watch what happens. Let me stop the lights. Not on red, okay? So we can do processing right at the edge. So if we were to lose connectivity, we could still detect things and take action. So you can see here this red light is going on whenever, right, whenever the vibration is sensed. We can do things like detect when connectivity is lost. So I'm going to pull the connection here to the PLC. And now we can do things at the edge like reach out to applications like WebEx Teams. So in WebEx Teams, it used to be called Spark, you have team collaboration space, the ability to have, there's open APIs, you can have bots, and those bots can pass data back and forth, and we can actually send data from this gateway into WebEx Teams or any other application. So you can see here, we've detected now that the Modbus PLC has been disconnected, right? And this notification here would then trigger action for IT and OT to go troubleshoot in their own interface. So I showed you the gateway management from the cloud. That's where IT would go and try to troubleshoot the problem. The OT person, they would jump into that system administration interface that I was showing you to check the state of the link. Plug it back in, and then it'll detect that change at the edge and do notification right there. That kind of edge processing is critical because in most cases, industrial applications, they need to react as soon as possible because every couple of minutes, it could be millions of dollars they're losing in production. So they want zero stoppage. You can see there now it says Modbus PLC ready. All right, so now we've got data coming in at the edge. We're making decisions on it. We're changing the flow of it. We're putting it into visualization in the fog layer. Well, we want to get it to some other app. How do we actually do that? Well, we provide controls with Kinetic, the Kinetic Data Control Module such that we can do very cool things like, say, I want to have multiple destinations for my data. Again, Amr mentioned this. You can support Azure, IBM IoT, AMQP broker, and that could be in the cloud or it could be even on-prem. And so it's basically anytime that data is going to leave your boundary, you get to decide how it goes out. So instead of setting all of your data, we allow you to filter it. So we have all these destinations. That builds from a connection from your data fabric out to these apps. And then we can create rules. And they can be really in-depth, or they could be lightweight. In this case, we're saying any type of data coming off this device that is vibration is allowed to go through, nothing else. So all the button presses, all the light status. 3? Yeah. OK. Cool. No worries. So we've got vibration and destinations, and then we merge them together in a policy. So we're saying, all right, we're going to send vibration data just to IBM Watson. If we jump over here into the Watson IoT interface, and I sign in, so we can open up the IoT cards. If you guys haven't played with it, it's actually pretty cool. You can build visualization really quick once you get data in there. And here we have Demo Kit 8, which is this guy here. That's now starting to monitor traffic in near real time. So we're streaming data to the cloud through our data control module, but just vibration shows up, none of the light status or anything else. All right, all happening in real time. So what we've done is gotten connectivity at the edge, secured it, extracted the data, normalized it, visualized it, been able to pass it to external applications, All of that required to get us to the state that the OT actually wants, right? They want to get that data that's trapped and locked away and be able to do something useful with it, like have this type of visualization. And we cover that from end to end.
So just, on the complexity of just onboarding those devices, Randy showed the GMM capabilities of and using the IRA29s with the LTE backhaul, how easy it is to actually just connect up these devices and get the data out of them. Then there's a highly distributed environments. Again, on the 829 is the best case for those types of things. But again, we've done it in other types of environments as well. Next slide. Yep. And then, yeah, thanks. And then, as these use cases evolve, we do, I think to your point, is like there's starting points that we're providing. Equipment health, machine productivity for CNC, the roadways examples, the oil and gas examples, gas detection monitoring, these types of things. But they're all powered by Kinetic underneath. And that means those developer screens that Randy showed with the visual editing and the policy editing and things of that nature, they're actually available. So while we have a supported aspect of the product, there's the extensions you can build on top of and continue doing that exploration of those use cases themselves. And of course, using StealthWatch and IND, you have control over segmentation. It could be in the forms of SGTs, but also being able to monitor that in ways like who's talking to who, all the benefits that come from NetFlow and things of that nature.